Put it like one of the desks.
What's up, YouTubers? Make sure you hit subscribe below and welcome to my channel. And go volleyball.
Saracen, you are the YouTuber.
I am the YouTuber. Alright, so first of all, I cannot have the -3. So on this graph here, I'd go back 1, 2, 3, and at -3, I would have no bueno, cannot have a -3. And then if I am graphing this and it's negative, that means I'm gonna be in this quadrant right here. So I'll have this like that, and then I'll have this here. Okay, so now that we have the graph, it's gonna be a lot easier to answer the domain. Is domain X or Y? X. Okay, so our domain is gonna be any X value but what? -3. So we're gonna say from -infinity to -3, union -3 to infinity. Are you watching? Okay, send me an email with the words quack quack, let me out.
You gotta do it later in the video too.
Oh, that's true.
You're gonna forget it and you're gonna be like,
Okay, the range is gonna be all of our Y values. We hit every single Y value because it goes down. We hit every single Y value up here, but we don't hit the X axis, which is a Y value of what? 0. So we don't hit 0. So our range is gonna be from -infinity to 0, union 0 to infinity. Okay, now increasing or decreasing, let's pretend like we're gonna call that Ben Cullison. He's got really short shorts on.
he's barking at people.
He's barking at people. Is he going up or down? Up, so increasing or decreasing? Good, so we've got increasing, and we're talking about X values here, so we're increasing on our X values, and it's actually gonna be the same as your domain. We're increasing on our entire domain.
Is it always the same?
It is always the same. Yep, there we are. All right, so we will take a look at the homework pretty briefly. We'll do the homework check, and then we will do topics 7 and 8 today. We're gonna graph, not gonna graph, but we're gonna look at graphs and answer some questions based off of new knowledge of vocabulary. And then we're gonna do some absolute value problems. And then your homework tonight is worksheet 3. Okay, should I pause it and not do the homework for these guys, or let them watch the homework?
let them watch
Okay. They want you to suffer. All right, can I get a volunteer with the homework to put under the camera?
No. If I do, can I get
Nikki.
Caesar?
Yeah.
Mine's
It's
not
gonna
bad.
take mine.
That's not mine.
That's
That's
not
mine.
mine.
No, no, what are you doing? No.
Sticker.
Can I just have a sticker?
Marco?
No, you still
This one.
It is not one of the questions isn't done. No. Too slow, buddy.
It's already done.
All right, for all of these folks,
Oh my god.
make sure for all of these, your range is from -infinity to 0, union 0 to infinity. So for all 3 of these, make sure your range is the same. Okay, now for this next one, your domain, you're saying that you can't have -5. And also, would this be increasing or decreasing on this domain? Let's draw it. If you're not sure,
Decreasing.
it is decreasing. This one's gonna look like this because it's positive over positive, so we're gonna have decreasing. Okay, and so you should have also said decreasing with the same exact answer as your domain. So same answer for decreasing. All right, the next one, like I said, the range should always be from -infinity to 0, 0 to infinity. We cannot have -1, which is why for the domain, we're restricting to -1. And is this an increasing or decreasing? It is increasing because this one's the negative. So if this is the negative, you're gonna actually have this graph like that. So that's gonna be increasing. Okay, last one here. We've got range again is the 0, and domain we cannot have a 3. This is the positive version here, so that's gonna be more like this problem, so we are gonna be decreasing. It's gonna look like this graph here. Questions on A, B, or C?
No.
Okay. Take a look at this one here, a little bit exciting. We got 3 and -9.
Can you do 2?
Sure. And then over here, it looks like we're getting n equals -8 plus or minus root 161. Do you want to do one of those two?
Sure.
Okay. All right, let's just do 2 of them and then we'll move forward. All right, so number 2, n squared.
For 1 on the part 2,
Mm-hmm.
when you add 19 to 8, it's 27.
Mm-hmm.
36.
And then 27 plus 9 is 36.
Yeah, that's what I shouldn't it be like 6?
So it should be 3 and -9. I can take a look at yours. Did other people get 3 and -9 on one?
No.
Yeah, I got 3 and nothing at mine.
Yeah.
That's
Okay.
what I got.
Let's do number 2 and see if that kind of answers your question about what happened. I can take a look at some people's in a second. Okay, so here, I'm gonna add the 25 to the other side. So I get n squared minus 4n, add the 25, and that gives me 21. Okay, now I have to take -4, cut it in half. What do I get when I cut -4 in half? -2, and then square -2? 4, so I need to add 4 to both sides. You can put a +4 here, or I can put it on the back end here. So now this whole thing becomes 25. And now let's go ahead and factor this. What adds to -4 but multiplies to 4? -2, so this is gonna be n minus 2 squared. I square root both sides. I get n minus 2 equals 5, and n minus 2 equals a -5. Add 2, I get n equals 7. Add 2, I get n equals -3. What questions can I answer? Feel okay on this one?
Yeah.
All right, choose between 3 and 4 for me.
4.
4?
Yeah.
Okay. Okay, in the same email, I want you to send me your worst fear. Mine is bubblegum.
What is that?
Could destroy the world.
Wait.
Logan said the word.
Wait, are you gonna like bring forth all our worst fears about what you're doing?
Am I gonna what?
Never mind.
All right,
Say it.
let's add the 40 to the other side. N squared plus 8n, and then I get a 30. Correct me if I'm wrong, is that good?
Yeah.
Okay, take 8, cut it in half. What do you get?
4.
Square it.
16.
Okay, so I'm adding 16 to this side, and I'm adding 16 to this side. Okay, so that should give me 46 over here. Okay, what adds to 8 but multiplies to 16? 4 times 4. So we're gonna have an n plus 4 squared, because 4 times 4 is 16, and 4 plus 4 is 8. So I'm gonna have a squared. Square root both sides. I get n plus 4 equals, if you want, you could just write a plus or minus root 46 right here. And then subtract the 4 to the other side, and you get n equals a -4 plus or minus root 46. Is that reducible?
I don't think so.
Root 46? I don't think so.
I don't think so.
Okay. How do we feel about this worksheet?
Good.
Okay. Do you think Marco deserves a sticker?
He deserves 2 stickers.
I see you said 2 stickers.
Be the sticker king before you know it. Okay. All right, notes out, please. We're gonna start a new topic. I find this topic more fun than what we did yesterday.
Guys, can I go get my snacks?
Yeah, go get your snacks.
Is it complicated or you think it's
I think it's pretty easy. Today's, I think, an easier day. Before we kind of jump into this, I wanted to tell you our plan. We're gonna do math today, tomorrow, and then Monday and Tuesday. We'll have 2 days of review. You'll have a 3-day weekend, and then you'll have 2 days to do your final. There's a half day here, which might end up being a ping pong day, or someone who needs more time on the final can take that. There's no school here, and it's the end of trimester 1 right there. So I would like to say congratulations on tying it up. Here are the possible prizes if your class wins. You can use your notes on the final and get +4. Or you can just get +8 on your final, but you're not allowed to use notes. So that's like a huge
The
prize.
finals on everything, right?
No, it's just gonna be on this last unit.
Oh,
That's the 11.
Or you could skip a test next trimester. The only reason is I can't let you skip the final. The college makes me collect them and mail them to the school, so I can't do that. I could also do a waffle day, and then you would get +4 on your final. You don't have to decide, you haven't won yet, but as a class, you're gonna decide on one of them. Okay? Let me just close the door. All right, let's do this. Vocabulary. Function is our first vocab word today. So a function is any expression that produces exactly one answer for any given input. Please get that definition down.
Are we doing all that?
No, you don't have to do the examples. Just write down the definition. We did this at the start of the year. This was in the Algebra 1 unit. Okay, so we have to determine yes or no, are these functions?
Oh, yeah, with the lines.
You're totally fine, it's easy. So on this particular situation, this one's not a function, but this one is, because what's the issue on this graph right here?
There's 2 negatives.
Yeah, the -2 goes to 2 different numbers, which is not allowed, because this says that the function produces one answer for any input. Well, actually here, -2 is producing 2 different outputs. That's not good. So this one's not a function. This one is a function. Okay. This one here, whenever you're given a graph, you're gonna do the vertical line test. Is there any place here that I can draw a vertical line and hit twice? So this one is a function. What about here? Is this a function?
No.
Not a function. Okay, because I hit twice, that is not a function. All right, this next one here, this is example 1 right here, and this is example 2. Any issues for example 1?
No.
Nope, so it's a function. What about example 2?
No.
Yes. Yeah.
Yes, you did.
Yep, so we've got 2 going to 7, 2 going to 8, that is not a function. Okay, because 1 is going to both -5 and 1 is going to whatever number that says, this is not a function. How about this one?
Yeah.
Function. And actually we would call this 1-to-1 as well, which we can talk about later. On your final, what do you care most about? You care most about the vertical line test. So I would give you a problem like these 2, or actually those 3, and I'd say which one is not a function? Which one's not a function here?
C.
Yep, because it fails the vertical line test. We ready to move on from that?
Yeah.
Okay. Okay, next one, go ahead and get this down. A 1-to-1 function. A function is 1-to-1 if the outputs never repeat. And you can use the horizontal line test to determine if a function is 1-to-1.
Miss, do you want an apple slice?
Yes. Thank you. Pretty solid, Nina.
A slice from underneath it, and they taste a lot better.
Okay, also in your email, tell me what snack I'm eating.
What if they can't see?
She did it right in front of
It's an apple slice.
I don't think that those live, so. we can see.
Do you think anyone's actually gonna email you? Just talking to you.
Oh, Afton, you're gonna email me, right? Bryn, maybe? No?
Often.
Barbie? Natalie?
No.
So often she won't do it and she'll do it.
Colton? Colton gonna email
No.
me?
No.
So I don't know.
What is it called to go with the
You
bottom?
probably won't even watch it.
Colton, are you watching this right now? Okay. This function right here is not one-to-one because it fails the horizontal line test. So this is not a one-to-one function. Why? Well, actually, if you were to look at this graph of y equals x squared, we can create a quick table for it. If you plug in -1 into x squared, you get 1. Plug in 0, you get 0. Plug in 1, you get 1. And so this is saying it is not one-to-one if you have outputs that repeat. This is a problem. Before we were looking at the x's repeating, now we're looking at the y's. And so since these 2 points share the same y value of 1, it's not one-to-one. And because we can draw a horizontal line and we see that that point exists for both, not one-to-one. Is this one-to-one? No. If I did a table for 2x minus 1, I'd get -7, -5, -3, -1. You can see that there's never gonna be a duplicate y value. And so we can test that by doing the horizontal line test. It only crosses once, it is one-to-one. We feel okay about that?
Yep.
I think that's brand new. I don't think you've ever seen that before.
I think it's that.
Oh, really? Not with me, I don't think. I had to research it. All right, next one is local min. If you don't want to write the definition, you don't have to. It's really obvious. A local minimum, there's a local min at a point if it's the lowest point in that general area. Okay, so taking a look here, tell me to stop when I'm at a local min. Yes, please tell me to stop. Local min, right here.
Min?
Oops. Okay, tell me when to stop.
Stop.
Yep, local min. I'm proud of you for not telling me to stop here. Everyone look in this dotted region right here. Some people might say that that's a local min, but is it the lowest point in that area? No, that would be the lowest point. So there's no local min there. What do you think the next word's gonna be? Local max. Okay, for a local max, there's a local max at a point if it's the highest point in that general area. Tell me when to stop. Here's my local max. You got it. Do we feel comfortable with that content? In calculus, we'll talk more about absolute maxes and versus local max, but not for pre-calc. Moving on like I heard of asparagus. Inflection point. Get the definition down, get the picture down, and then we'll pick back up.
Wait, wouldn't it be a inflection instead of an inflection?
You're talking about you think I should have no N here?
Yeah,
There should be.
there is a inflection.
No, because that's a vowel, so you need an N.
Oh, my bad.
This one.
Mr. Gorney would be proud of me. teach an English and math class. What I've drawn for you here is a masterpiece, also known as a coffee cup. Okay, if my coffee cup is upright, we are gonna call this concave up. So anytime you have something like a parabola that looks up, that's concave up. If I have a coffee cup that's down, and I've drawn it, that's concave down. The coffee cup has been turned upside down. Okay, so we need to know this phrase of concave up. See how my coffee cup is up? And then here my coffee cup is down. And there happens to be a point when it changes concavity. It changes from being a coffee cup that's up to a coffee cup that's down. And it's not gonna be super precise, but do your best to indicate where does it go from coffee cup up to coffee cup down. Or better language would be concave up to concave down. So this is an inflection point. How do we feel about that word? Yeah, not too bad. How do you feel about my drawing?
That's pretty good.
Okay, if you're watching this, rate my drawings on a scale from 0 to 46.
What's the chance that you think it gets a 46?
High, because I'm pretty much a star.
Love it.
All right, see if you can find the inflection point in your brain. Not in your brain, but like in your brain, try to find what it is here. There may- Okay, tell me when to stop here on my inflection point. Yep, there's one right there. Concave up, concave down. Okay, tell me when to stop. Good. Concave down, concave up.
Stop earlier.
Concave down the whole way.
Yeah.
Here?
Well,
That's just a line. So those are the only two. They usually look like little snakes, S's. Okay, let's try over here. Tell me when to stop. There you go. Concave down, concave up. That's a complicated one. They tend to be more like that. All right. Range. If I put arrows on here, remind me that range means what? X's or Y's? Y's. So the range on this problem, my Y goes all the way down, my Y goes all the way up. What's my range on this problem?
Negative, positive.
You got it. Okay, also email me your favorite Ninja Turtle. Now, what if in this problem, instead of having arrows, what if I changed it to a point here and a point here? And it's hard to read, but that says -1 and that says 1. So what's my range now? Y value to Y value. What's the lowest I've gotten to? What's the highest I've gotten to? Okay, so the range would be from -1 to 1. That's review, but do we feel okay about that?
yes.
I know that there's a lot of information being thrown at you for actually one problem that's about to come up. Okay, tell your neighbor what the range is on this one. Okay, I just heard it. I heard it as -10 to 16. Okay, also email me telling me if you think that knitting makes someone more attractive or not.
Ew, I don't.
Nope. You don't think knitting makes someone more attractive?
No.
Do you know this one?
Oh yeah, yeah, totally. Okay, last one. End behavior. If I have arrows on this, I'm asking you, is it true as x goes to infinity, is my f of x going to infinity? When I say x goes to infinity, am I saying left, right, up, or down here? X. Right. So I'm saying as x goes right, my y does what? Go up. Is that true? As I go right, am I going up?
Yeah.
Okay, so that is true. So this is review. What about now? What if I put endpoints? Is it true that as I go to the right, my function is going to infinity?
No.
No. Everyone hear that? That's 1 point on your final. Okay, if there's an endpoint there, it's not going on forever. So this would be a false statement on this graph. If I have, it's going right, it's going to infinity, I would need an arrow to indicate that's true, but I don't, it's an endpoint. All right, you ready to put everything together? Here's what your question will look like.
No.
Here's your graph.
Aw.
You have to circle the letters of the correct statements. So you and your partner are on your own if you'd like. You're gonna go through and you're either gonna write down the letter that's true or kind of circle A, etc. So tell me which statements are true. Go ahead and try this for a second. Next period, I should be like, I'm not teaching you. You can just watch my video.
So yeah, you should.
You do it for like the first 5 minutes of that.
It's a grand premiere.
It's what?
It's a grand premiere of your video.
Yes.
You
How
see
fortunate
someone-
they are to watch it.
You didn't get like so much views on there. You gotta watch a lot. Student.
Miss, if you just take videos of yourself in the morning, then you won't even have to teach midday.
Perfect.
Exactly.
They do have flipped classrooms where teachers have students watch videos at night and then come in and just practice. Problem is, a lot of people don't watch the videos, then they miss the whole
That
lesson.
works in theory, but not in reality.
It depends on the group of students. Give you 1 more minute to finish this problem.
How much do you want to bet that's been?
I was just thinking that. Okay, let's rally. So we have to circle either A or B. Is this a function, yes or no?
Yes.
Yes. This question right here is all about the vertical line test. Okay, here it does pass the vertical line test. There's nowhere where I can draw a vertical line and hit the graph more than once. So this is a function. Okay, the next one is about the horizontal line test. Does it pass or fail the horizontal line
It
test?
fails.
It fails. It just crossed 1, 2, 3, 4 times. It is definitely not 1-to-1. A lot of the y values repeat, so this is not 1-to-1. Is -3, 0, is that point a minimum?
Mm-hmm.
Yep. Is -4, 0, is that point a maximum? Nope. Is -4, 0 an inflection point?
No.
No. Okay, now let's take a look at this. As x goes right, y goes up. As x goes right, y goes up. That's true. As x goes to the left, y goes down. Is that true? So just B, D, G. We're gonna try one more. There we go. Here's your next problem. Okay, circle the ones or write down the letters that is true, and you guys need to refocus. Okay, you're wonderful. I adore you. Okay, here we go. Function, yes or no?
Yes.
Okay, yes it is, because it passes the vertical line test. There's no place where I could put a vertical line where it hits twice. Okay, does it pass the horizontal line
Yes.
test? No, so it's not 1-to-1. Is negative 216, is that a minimum? No, it's actually a what? Maximum. Okay, next one is 0, 0 a maximum? No, it's actually a minimum, okay? Negative 1, 8, is this a point of inflection? Yes, it is. We have concave down to concave up. As x goes to the right, y goes down. As x goes to the right, does y go down forever? No. As x goes to the left, y goes up. Does this go up forever as we go to the left? No, those are the only two true ones. Okay, I'm going to hand out your worksheet. You're gonna do the top part. Here I go, handing these out to you. By the top, I mean the first page, 1 and 2. Take one, pass one back, Okay, we're doing problems 1 and 2. We're doing problems 1 and 2.
Miss,
Yes.
since they don't have arrows on it, would we just assume that they're points?
For the homework, there's just put endpoints on both problems 1 and 2. There's no arrows, so put endpoints. You guys hear that? Put endpoints on problems 1 and 2. I should have done that before I copied it.
Oh, there's 2 on one.
Yeah, put endpoints for me.
Alright.
Apologize. Anyone here still need to take their tests?
Oh, me.
When are you taking yours?
I can do it next week.
Next period? And then what about you, Mark?
I have PE next period.
Go 1 more minute on this, and then we're gonna move on to our last topic of the day, which I would actually call possibly easier than this.
I said possibly.
I don't know, because there was a lot to learn about this. It wasn't hard.
You should do some like Dos Plus Uno or something. Wait, did you do cheerleading?
Yes. For 1 year. I wanted to brag and flip across the gym.
Nice.
Okay, team, we're moving on. Let's go. Here we go. Last topic of the day is absolute value equations. A lot of this is actually review. We have done this again in the first unit, but I'm tying it back into this unit. What is the definition of an absolute value? It is the distance away from 0. So how far away is -3 from 0? 3. Okay, how far is 4 away from 0? 4. So we can also think of this as the absolute value of a negative is always a positive. The absolute value of a positive is always a positive. We should know that. Okay, next slide. Here's our first problem of 3 that we're gonna do with this topic. Go ahead and get it down.
that solve for x?
Mm-hmm.
That's four, that's all right. At least four. Is it for x, so you have to.
Is it because there's a weird space between the F and the
Yeah,
OR?
so like for x, or it's-
Yeah, that's because I'm an equation editor. Yeah, it's one word here, 4. Okay, so this is saying substitute in 11 for g of x. So that's saying that g of x right here is 11. So I could rewrite this as 11 equals this. Or we could rewrite this as the absolute value of 4x minus 1 equals 11. Does anyone remember? There's a couple arrows we have to do. Anyone remember this? We did this first unit. Yeah, plus or minus. So we take our arrows, we go like this. And we have one equation which is 4x minus 1 equals a positive 11. But then we also get 4x minus 1 equals what? Yeah, and the reason why is because we could get a negative 11 in here, and then the absolute value of that gives us our answer of 11. All right, so we're gonna add 1 to this side. We get 4x equals 12. Divide by 4, and x equals 3. Okay, next one here, we add 1. That gives me 4x equals minus 10. Divide by 4, and I get x equals negative 10 over 4. And I can simplify that by dividing both of these numbers by what? 2. What does that reduce to?
5
Negative 5 over 2. And that's my second answer. Okay, so if I were to summarize that, you basically just split it into 2, let 1 be the positive and then 1 be the negative, and then we just solve. Do you guys remember this?
Yeah.
Okay, good. All right, next one, I'd say is even easier. For the same exact problem, evaluate the function for x equals minus 2. When I say evaluate, that's a fancy way of saying something that starts with a P.
Push B.
No, not push and P. Take x equals minus 2 and plug it in. Okay, if we're evaluating, you're taking minus 2 and you're plugging it in. Go ahead and try that on your own. Can someone confirm that they got 9?
Yeah.
Okay, just be careful. You're ignoring the absolute value until the very end. And so you get a negative 8 here, but don't do anything yet. Drop down the minus 1, do your subtraction. Once you get your answer, make a positive. Okay, last one. State the domain and range. Same problem, same function, I mean. Okay, domain, tell me, is domain x's or y's? X's. And so the question is there a possible x value that I cannot put into my function? Do I have any issues plugging in any number for x here? 0? I can do 0. 4 times 0 is 0, minus 1 gives me minus 1, absolute value of that is 1. There's no issues. So there's no issues. I don't have a denominator which could possibly be 0, so our domain is from negative infinity to infinity. My range is all possible what values? They are going to be positive, and they're also going to be bigger than the number 0. So this question is saying for absolute values, what are my outputs? Well, if I plugged in 1/4 here, I'd have 4 times a 4th, which is 1 minus 1. I'd get absolute value of 0, which is 0. So I can get 0 for my y value. Can I get any negative numbers?
No.
No, because the absolute value of anything is positive. So my range is going to be from 0 to infinity, Why did I put a close bracket on 0?
Equals to 0.
Yeah, because I can get 0. And so this is a fancy way of saying that I'm gonna get all positive numbers from this. Okay, we're gonna do one all together, and then I'm gonna let you finish your homework. Okay. Next thing that you guys have to email me about, I want you to tell me what you think of Ben Cullison's drawing of me.
Oh, didn't you do that in Math 101?
Yeah, there it is. Okay, I'm gonna keep this here for inspiration. Alright, if g of x equals 2x minus 5, or absolute value, solve for x if g of x equals 9. So my first task is to set 2x minus 5 equal to what? 9. And then I set 2x minus 5 equal to negative 9. Can you guys quickly solve that for me? Let's go, Courtney and Over solve the top. You guys on this side solve the bottom for me.
Nice. 2.
X equals 2.
2?
Yeah.
Negative 2?
Negative 2.
Did you even get a chance?
That's what I do.
Yeah, negative 2.
Say that, right?
Good, we're done. Done with A. So now for B, it says basically plug in minus 4. So let's do it in our heads. What's 2 times minus 4? Negative 8. Negative 8 minus 5? Negative 13. 9, 10, 11, 12. Yep, and then absolute value of negative 13 is 13. Okay, all we did was take minus 4 and plug it in here. 2 times minus 4 is negative 8. Negative 8 minus 5 is minus 13. Absolute value of that is this. Okay, the domain and range never changed. Domain means I can plug in anything. What's my domain? Negative infinity to infinity. I can plug in any x values I want. But for my y values or my outputs, they're always going to be positive, but they could be 0. So what's my range?
0 to infinity.
You got it. And we are done for the day. So flip your paper and do the last problems on the back. Thank you for watching. Make sure you hit subscribe.
Let me know.